In this video, we're going to talk more about naming alkanes. Specifically, we're going to address alkanes that have more complicated substituents. Some examples of complicated substituents are shown here. You can see that these substituents do not have simple names. The simple name, for example, for a 3-carbon chain would be propyl, but if it's connected to the middle carbon of a 3-carbon chain, we can't use propyl to describe it anymore. So we have to come up with another way to name it. There are two ways to approach this. You can name and number these more complicated substituents based on the point of attachment and put that in parentheses, and I'll show you how to do that. Or you can use the common name that's shown here. Let's do a quick example with the Tbutyl group. In this example, our parent chain is here, and we have this complicated substituent attached at position 1, 2, 3, 4. We can use the common name Tbutyl or Tbutyl, and if we do that, it becomes 4-Tbutyl, or you can use Tbutyl, octane. Octane for the 8 carbons in the parent chain, and the 4 comes from the number that it's attached to, 1, 2, 3, 4. So that's how you would name this using the common name Tbutyl or Tbutyl. The other thing that you can do is you can name and number based on the point of attachment. That means that you would number starting at this carbon here. So this becomes carbon 1, and this becomes carbon 2. At carbon 1, we have 2 methyl groups. So that's why we have a 1,1 dimethyl. It's an ethyl group because the parent chain here is 2 carbons long. So this is kind of like our mini parent chain. So we would call this molecule here 4, because this group is at position 4, dash 1,1 dimethyl ethyl. Put that whole thing in parentheses and add octane on the end. The ethyl here refers to the 2 carbons in the parent chain as numbered from the point of attachment to the parent chain. And by putting this in parentheses, we're saying that all of this is attached to carbon 4 of the parent chain. If I ask you to name a molecule, you can use either approach, and sapling should also accept either approach, but you should also be familiar with both forms in case you're given a name and have to draw a structure or identify a structure that's associated with that name. Some tips if you want to commit these to memory. You can see the N over here in N-propyl and N-butyl. That actually stands for normal. The iso in isopropyl and isobutyl refers to isomer, and you want to think of this as having that little Y shape. The sec in sec-butyl refers to secondary. This carbon is secondary because it is attached to 1, 2 other carbons. In tert-butyl, the tert stands for tertiary. So this carbon here is attached to 1, 2, 3 other carbons. Sec and tert can be abbreviated as S and T respectively. Keep in mind that when you're ordering in terms of alphabetical order, the sec and the tert does not count towards the alphabetical ordering, but the iso does. Now that we know a little bit about nomenclature of alkanes, we can talk briefly about octane rating. You can see isooctane shown here, which stands for isomer of octane, right? It's not the normal straight chain octane. And its IUPAC name is shown here. And we went over how to name that in the previous video. We also have N-heptane shown here. And remember that N stands for normal. So this is just the straight chain heptane. Isooctane has an octane rating of 100, and N-heptane has an octane rating of 0. Octane is one measure of gasoline performance. The higher the octane number, the more compression the fuel can withstand before detonating. So isooctane can withstand more compression than heptane. The octane rating of gasoline is defined based on the mixture of isooctane and heptane that has the same anti-knocking capacity as the fuel that they're testing. So for example, gasoline with the same knocking characteristics as a mixture of 90% isooctane and 10% heptane would have an octane rating of 90. The octane rating of 90 does not mean that the gasoline necessarily contains isooctane and heptane in these proportions, but just that it has the same detonation resistance properties. Let's look at a couple more examples. Here we have our parent chain. This is 1, 2, 3, 4, 5, 6, 7 carbons in length. So we have a heptane, It doesn't matter which way we number, we're going to get the substituent on the same number, 1, 2, 3, 4, or 1, 2, 3, 4. So our substituent can be named either two ways. You can recognize that it is an isopropyl group, and you can just say 4-isopropyl heptane, or we can use the parentheses method where we say that our parent chain is 2 carbons long, starting at the point of attachment to the parent chain, 1, 2 carbons. So that becomes an ethyl group. And there is a methyl group attached to position 1. And that's the methyl group there. So in that case, it would be a 4-1-methyl ethyl heptane. And either of those names would be acceptable. Let's do one more example. Here's our parent chain shown here. We have 2 methyl groups and then a more complicated group over here. First, let's number our parent chain. We want to number 1, 2 from the left to put our first substituent at position 3. If we number from the right, we don't get our first substituent until 1, 2, 3, 4, 5. We have 10 carbons, so that gives us a decane. We also have methyl groups at positions 2 and 3, so that becomes a 2,3 dimethyl. Our group over here in blue can be named using 2 possible methods. We could call it an isobutyl group. And if we did that, we would have a 6-isobutyl 2,3 dimethyl decane. Alternatively, we can use the parentheses method. So you can go 1, 2, 3. There's our parent chain with a methyl group at position 2. That then makes this group a 2-methyl propyl. Propyl coming from the 3 carbons of the parent chain, and the methyl group is attached to position 2. If we do things this way, we have a 2,3 dimethyl 6,2-methyl propyl decane. Notice that the position of the methyl changes depending on how we name this group. If it is an isobutyl group, then we use I for alphabetical ordering, and I comes before M for methyl. If we use the 2-methyl propyl name, methyl comes before methyl propyl alphabetically. This concludes the video for naming of alkanes. We'll cover cycloalkanes in the next video.